There's a common complaint by students, of course not by instructors, but by students, is that the questions on the tests are nothing like the homework or nothing like that was presented in class. But you know, the typical instructor answer goes like this: well, it is exactly like the homework or exactly like the stuff in the class, but not, you know, it's not. There are different levels. One is just to be able to regurgitate the information. You know, you've seen it before, you can just regurgitate what you've seen before. The other is actually to see a pattern, or to see it's similar. And so the pattern was this. This is what I talked about earlier. Carbon, no problem. Carbon dioxide, no problem. Carbon trioxide, a big problem. What is the big problem here? The big problem is this. The range for carbon goes from -4 to a max of +4. So once we hit CO2, we've topped out at +4. Once we hit carbonate, we've topped out at, what's the charge on carbonate? We've topped out at +4. If we go to carbon trioxide, what are we at now? +6, which exceeds the max. Now, why is there a maximum? We're going to talk about that later, but for right now, we just want to see some data and understand. You'd be able to use these kind of patterns, use simple patterns. What about for sulfur? What was the range for sulfur? +6, -2. Remember, we'd written those down. And so we don't expect this because that exceeds the max that we'd expect for positive carbon. And so that was the answer to that one. Okay, so it is. To me, this is the problem. Is just like the carbon dioxide problem we did earlier. But you know, you might not see it because you're not that intimately familiar with it, and then obviously it's harder to see. But like Pasteur, he was intimately familiar with bacteria and how it grows, and so he came up with that quote, right? Chance favors the, what was it? Chance favors the, you know, if it was some dishwasher coming in to wash the Petri dishes, penicillin would never have been discovered, right? Because the dishwasher wouldn't have cared and wouldn't have thought anything of it. But because I think he's the one who came in to wash the dishes, he saw that and he recognized that. And so chance favors the whatever. And so the same thing here, you know, you'll be able to answer these questions more. But if you don't recall this one, then it's not going to happen.
Professor, so the answer you were looking for was just the explanation of the difference between charges of the two different elements?
No, the answer I was looking for is it exceeds the maximum. It exceeds the maximum. For example, here, AlCl3 is no problem. We call that aluminum chloride. But what about AlCl4? You know, if aluminum chloride forms like this, why can't I have AlCl4 or AlCl5 or AlCl6? Because aluminum has what charge? 3+. Therefore, I'm not going to have AlCl4, am I? And so what is the maximum positive charge on carbon? Okay, what's the maximum positive charge on phosphorus? +5. If the maximum positive charge on phosphorus is +5, PlCl5 is going to max it out. Now, if I have PlCl6, that can exist as long as there's a negative charge, because that's going to maintain phosphorus in the 5 state, and then 6. But the sixth one is not going to balance. So I put 6 chlorides, I'm going to end up with a net -1 charge, but it's not going to change phosphorus. And so that was the connection there with the CO2. Because it was just phosphorus, because I told you nitrogen, what's the charge on nitrogen run from? Nitrogen runs from -3 to a max positive of +5. Phosphorus is in the same family. Right. If it's in the same family, we expect it to be the same, -3 to +5. And I talked about 8s. For example, this is phosphate. Does perphosphate exist? think I might have asked this, or I might have asked a different, sometimes I ask this one, sometimes I ask a different one for PERS. But this is the exact same question, not just once, but repeatedly, it's the same concept, but perphosphate does not exist because perphosphate would be PO5 3-. That can't exist. Why not? Because the charge would be +6 on phosphorus. Do you guys recall this kind of discussion before? Yeah. And so it's just applying it to this, you know, we talked about the PERS, whereas chlorate, yeah, chlorate's not a problem because chlorine in chlorate, and I was going to talk about it then when we were talking about chlorate. I was thinking, yeah, maybe I'll do it now. In fact, the example I was going to give you was, what was it? It was going to be ClO5-, but then I switched it to PF6. But ClO3- is not a problem. In nature, where does the 8 come from? In nature, 8s come from, you know, these are, because we live in a what we call an oxidative environment. Our atmosphere is filled with 20% oxygen. You know, it's not an anaerobic. In an anaerobic environment, there's no oxygen. So in an anaerobic environment, the metals aren't corroded. And in an oxidative environment, or aerobic environment, that like we live in, all the metals are corroded except for gold, you know, platinum, the noble metals. Right? Copper is not. You know, copper is going to be corroded. Silver will start to corrode also, but silver stays good. You know, they sell lots of silver polish and other things that maintain the luster, but the silver polish is just abrading off the surface oxide. You're losing silver when you use silver polish, so it's going to weigh less. And so this is normal. In normal oxidative environment, we get this, but you know, it's just because of the nature of chlorine. I mean, chlorine has, to go to perchlorate. Perchlorate is very unhappy. Perchlorate. Do you know what they use perchlorate in? Perchlorate is extremely unhappy. Unfortunately, so unhappy that I think 2 people died in Nevada. You know, there's a perchlorate manufacturing plant just north of Las Vegas. Perchlorate plant in Nevada. Have you seen this? Pepcon is it called. Pepcon. Let's go to, maybe I don't want to waste time. I mean, even though I'm going on these sites, it's not a complete waste, I think, because you're learning a little bit, hopefully, of this, and a lot of this is memorization, right? How do I know perchlorate? How do you know perchlorate's unhappy? Because you learn it, right? And so you want to see what happened at the perchlorate plant in Nevada. Let's watch this here. I think I turned off the audio. So let me turn it back on audio here. Okay. Hopefully the audio is working.
See, I didn't see no cars leave at all.
No.
What's that over there?
There was lots of cars. We haven't seen anything or even the area.
Oh!
Ooh, that's gonna be loud.